We write them out as the product, each one of them as the product of activity coefficient times the mole fraction. Also, what I've done here is assume that the pressure is less than or equal to about 20 bar. Because if not, then I'm going to have to put a pointing factor out in front of this thing as well. But if this situation is okay, then K just decomposes into the product of K formed out of the activity coefficients times K formed out of the liquid phase mole fractions. Now again, all of the individual activity coefficients depend on composition. So the only way I can do this would be to solve it iteratively. I would start out by assuming an ideal solution with all the gammas equal to 1, get a provisional set of x's, use those x's to evaluate the gammas, assuming that I've got expressions for those, and then calculate a new k gamma and iterate it to convergence. Now this kind of a situation is kind of rare, where you have reactions among these liquid phase components at something other than very small mole fractions. The more typical cases are where you have reactions in dilute solution amongst the components that are solutes, where the solvent doesn't really participate, it's just the medium. And so we might have reactions that look something like this: A plus B goes to C, all of them at very low concentrations in the solution. That's a typical situation that you might run into. Now if Henry's law holds, then K is just equal to either Kx or Km. For this, Kx would just be equal to, in this case I can write it out as Xc over Xa, Xb. Or if I'm going to use molalities, then I'm writing K here expressed in terms of molalities as MC over MA, MB. And I have standard states actually given for components that are likely to be present in these types of reactions. We can find in the tables the solute standard states are given. So we have standard state values for all of these species, presumably in our tables. So we can use, as before, the same methods for determining the thermodynamic equilibrium constant, which would be reducing then to these guys. Now, if non-ideality has to be accounted for here, then I would need to adjust with these Henry's law type activity coefficients, either in terms of mole fraction or in terms of molality, more often in terms of molality, so that these don't present any additional problems for us. This might be it. So that's it. That's the problem with these things. They go kind of fast, unless you stop me with questions. But I think that's enough material for you for one day. So you can look ahead for tomorrow and Wednesday if you want, and print them out ahead of time to help you take notes or whatever you'd like to do with them. But what I'm going to do is go back and now repost this with the corrections that I made for the typos, and I'll do the same thing tomorrow. I'll go through it, probably find some typos, fix it up, repost it, and go on like that. So everybody okay? Okay.